Imagine a future where we ascend to space, not with roaring rockets, but with graceful ease. A future where the journey to the stars is as smooth as an elevator ride, where the boundary between Earth and space blurs into a seamless transition. Picture a ribbon shimmering in the sunlight, stretching from our planet's surface towards the inky blackness of space. This ribbon, a marvel of engineering, would be our bridge to the cosmos, a lifeline connecting us to the vast universe beyond. This is the dream of the space elevator, a concept that has captivated scientists, engineers, and dreamers for decades. It's a vision that combines the ingenuity of human innovation with the boundless possibilities of space exploration. Our journey begins with a question that has echoed through human history. How do we reach the stars? From the earliest days of stargazing, humans have been fascinated by the heavens, yearning to explore the unknown. For centuries, rockets have been our answer, powerful machines hurtling us upwards against the pull of gravity. These fiery behemoths have taken us to the moon, to distant planets and beyond. But they come with limitations and immense costs. But what if there was another way, a more elegant solution inspired by the very structure of our planet? A method that could revolutionize space travel, making it more accessible and sustainable for future generations. The answer lies in a concept that sounds like science fiction, a cable tethered to Earth, reaching out to the heavens. This cable, anchored to the ground and extending into space, would be a monumental feat of engineering. This cable, strong enough to withstand the immense forces at play, would serve as a conduit, a pathway to the cosmos. Made from advanced materials, it would need to be incredibly durable, capable of withstanding the harsh conditions of space. Along this cable, climbers would ascend, carrying people and cargo, opening up a new era of space exploration and utilization. Imagine a world where transporting goods to space is as routine as shipping cargo across the oceans. Join me as we delve into the fascinating world of space elevators, exploring the science, the challenges, and the tantalizing possibilities that await us if we can turn this dream into reality. Together, we'll uncover the potential of this groundbreaking technology and envision a future where the stars are within our reach. A space elevator, at its core, is a simple concept. Imagine a cable incredibly strong and lightweight, stretching from the Earth's surface to a point beyond geostationary orbit, approximately 36,000 kilometers above our planet. This cable would be anchored to a platform on Earth, likely located in the ocean, and counterbalanced by a weight in space, perhaps a captured asteroid. The principle behind its operation is equally straightforward. The Earth's rotation creates centrifugal force, which acts to fling objects outward, much like a stone spun on a string. The space elevator's counterweight, positioned beyond geostationary orbit, would experience a greater centrifugal force than the Earth's surface, keeping the cable taut and the entire structure upright. Along this taut cable, climbers, powered by electricity or lasers, would ascend, carrying people and cargo to space. This journey, unlike the violent thrust of a rocket launch, would be a smooth, gradual ascent, opening up space travel to a wider range of people and purposes. The elegance of the space elevator lies in its simplicity, but the science underpinning it is anything but simple. The concept of a space elevator has fascinated scientists and engineers for decades, promising a revolutionary way to access space. To understand how it works, we need to delve into the realms of physics, specifically the interplay between gravity and centrifugal force. These forces are fundamental to the operation of a space elevator. Gravity, as we know, is the force that pulls us towards the Earth's center. It is a constant force that affects every object with mass, giving us weight and keeping us grounded. It's what gives us weight and keeps us grounded. Without gravity, we would float aimlessly, unable to stay anchored to the surface of our planet. Centrifugal force, on the other hand, is an outward force experienced by objects moving in a circular path. This force is not a fundamental force of nature, but rather a result of inertia, the tendency of an object to resist changes in its state of motion. It's what makes you lean into a turn while driving or pushes you outward on a merry-go-round. This force is crucial in the design of a space elevator, as it helps counteract the pull of gravity. In the case of the space elevator, these two forces are in a delicate balance. The cable must be strong enough to withstand the gravitational pull while also being able to handle the outward force generated by the Earth's rotation. Gravity pulls the cable and the counterweight towards Earth, creating a downward force that must be countered to keep the structure stable, while the centrifugal force generated by the Earth's rotation acts to fling them outward. This outward force increases with distance from the Earth's surface, making the positioning of the counterweight critical. The key is to position the counterweight at a point where the centrifugal force is greater than the gravitational pull, keeping the cable taut and the entire structure upright. This balance is crucial. The counterweight must be placed at a specific altitude where these forces are perfectly balanced. If the counterweight were too close to Earth, gravity would win and the structure would collapse. The cable would not be able to support the weight, leading to a catastrophic failure. If it were too far, the centrifugal force would be too strong, potentially ripping the cable apart. This would result in the cable snapping, causing the entire system to fail. The precise balance of these forces is what makes the concept of a space elevator both challenging and fascinating. Section 4. Anchored to Earth, reaching for the cosmos. The location of the space elevator's base on Earth is not arbitrary. It is a decision that involves meticulous planning and consideration of various factors. It needs to be strategically positioned to ensure the structure's stability and minimize the risks posed by natural phenomena. Engineers and scientists work tirelessly to identify the most suitable sites. The ideal location is near the equator, where the centrifugal force is strongest due to the Earth's rotation. This force helps in maintaining the tension in the elevator cable, which is crucial for its functionality. Furthermore, the base needs to be situated in an area with minimal seismic activity and favorable weather conditions. This ensures that the structure can withstand environmental challenges without compromising its integrity. This has led many scientists and engineers to propose an ocean-based platform anchored to the sea floor as the most viable option. The ocean provides a stable foundation and the ability to avoid densely populated areas. Such a platform would offer greater stability and mobility, allowing it to maneuver away from potential hazards like storms or space debris. The dynamic nature of the ocean platform makes it an adaptable solution. The counterweight, positioned at the other end of the cable, plays an equally crucial role. It is essential for maintaining the balance and tension of the entire structure. It needs to be massive enough to provide sufficient centrifugal force to keep the cable taut. Engineers calculate the precise mass required to achieve this balance. One intriguing possibility is to capture an asteroid and use it as the counterweight, effectively recycling a celestial body for our spacefaring ambitions. This innovative approach not only solves the problem of finding a suitable counterweight, but also demonstrates our ability to repurpose natural resources for advanced technological applications. The dream of a space elevator is a testament to human ingenuity and our relentless pursuit of progress. By anchoring ourselves to Earth while reaching for the cosmos, we bridge the gap between our terrestrial origins and our extraterrestrial aspirations. As we continue to innovate and push the boundaries of what is possible, the space elevator stands as a symbol of our potential to transcend our limitations and explore the vast expanse of the universe. Section 5. First Visions of a Vertical Journey. The concept of a space elevator is not new. It first appeared in the scientific literature in 1895, thanks to the visionary thinking of Russian scientist Konstantin Tsiolkovsky. Inspired by the Eiffel Tower, which was a marvel of engineering at the time, Tsiolkovsky imagined a similar structure, but on a colossal scale, reaching into space. However, Tsiolkovsky's vision was purely theoretical. The materials needed to build such a structure simply didn't exist at the time. It wasn't until the discovery of carbon nanotubes in the 1990s that the space elevator moved from the realm of science fiction to a tangible engineering possibility. Carbon nanotubes are incredibly strong and lightweight, possessing the very properties needed to create the space elevator's cable. This discovery breathed new life into the concept, sparking renewed interest and research into its feasibility. Section 6. A Stairway to the Heavens. Practical Applications. The potential applications of a space elevator are as vast as space itself. It would revolutionize space travel, making it more affordable, accessible, and environmentally friendly. Instead of relying on expensive and polluting rockets, we could simply ascend to space, carrying people, cargo, and even spacecraft. Imagine space tourism becoming commonplace, with people from all walks of life able to experience the awe-inspiring vista of Earth from orbit. Scientific research would be revolutionized as we could transport telescopes, observatories, and even entire laboratories to space with ease. The construction of space-based infrastructure, such as solar power stations or space habitats, would become significantly easier and more cost-effective. The space elevator could even serve as a launch pad for missions to other planets, providing a gentler and more efficient way to escape Earth's gravity well.